In a prior movie, I talked about how we can switch between metric units, like kilometers, meters, or millimeters, for example. We can use the latter method to do that. Well, there's another method to switch between units that's even more powerful. It's perhaps a little less obvious to understand at first, but once you get it, it's super simple, and it will allow you to convert between any units, not just metric units. And it's a super great thing to understand and have under your belt. So the first thing you need to understand to use this method is a little bit of algebra. If we take a number divided by itself, for example, 8 divided by 8, that equals 1. Hopefully you know that already. It doesn't matter where that number shows up on top and bottom, numerator and denominator, that always works. So for example, again, I could do 8 times 4 over 8. Okay, and the rules of multiplying fractions mean you multiply across the top and across the bottom. So what you get is 8 times 4 all over 8. And you can pull out the times 4 on that. So all of these things that I've written here, these expressions, are all the same. And once again, we have 8 divided by 8, and that equals 1. And we all know that 1 times 4 is 4. So what this illustrates is that if you have a number or anything on top in the numerator of your big long multiplication problem, if you have that same thing in the denominator, those two, we say, are going to cancel. The 8's cancel. Okay? So really, I didn't need to go through all this extra work. I just did on purpose to show you every little step to get to that final point. So one more example of that would be, and I'm going to go a little bit bigger than this. Let's go 2.5 times 3 divided by 2.5 times 8 divided by 3. Hopefully you can tell by now that I like the number 8. And here we have a situation where we have a couple pairs of numbers where they're both on top and the bottom. We've got 2.5 on top and bottom. So I'm not going to bother with all this extra shuffling around that I did over here. I'm just going to recognize that if I have a number on top and bottom, they're going to cancel, so I can cross those off. I also have a 3 on top and a 3 on bottom, so those cancel, and my final answer is 8. So that's pretty nice to be able to do that, right? If I wanted to do all this by hand and actually multiply all this stuff out, it would be super tough. But with cancellation, we can do this stuff really quickly. Okay? This doesn't just work for numbers. If we look down here, I've got some imagery, and you'll notice that I've got the same sort of pattern that I did up here. I have some shapes where the shape is on top and on bottom, and you can see that the orange circles and the blue squares, they cancel, leaving just the triangle. Okay, so just like I did with the numbers, if I've got the same shape on top as I do on the bottom, then I can cancel those out, and what's left over is the final answer. Final note, you don't have to have them in this perfect order, right? If you have anything on top and that same thing on the bottom anywhere else, they cancel. For example, green star on top, green star on bottom, they cancel. Red octagon on top, red octagon on bottom, they cancel. Heart on top, but not on bottom, well, that stays. That's going to be in the final answer. Same with the lightning bolt, only on bottom, so in the final answer, that's on the bottom. Again, cancellation made this problem pretty easy. Knowing that problem, let's solve these two. Sorry, knowing that pattern, excuse me. We've got this gray pointy shape on top and on bottom. Those are going to cancel. We've got the black diamond on top and the bottom. Those are going to cancel. Hopefully you know the answer by now. Pause the video and think about it if you need to. Okay, final answer. You've started playing the video again, and I'm looking for an orange pen so I can draw an orange circle. That's the final answer. And by the way, in case you're curious, is that orange circle on the top or the bottom? It's on top. So we don't need to draw a denominator rather, because there's only this one thing on top. Pause the video again. Take a look at number 4. See if you can do this yourself. I'll wait a second. Okay, you've hit play again. I'm going to walk through the solution. We're looking for things that are on the top and the bottom, so we can cancel them. We've got square on top, square on bottom, and this time my answer blank is different. I'm not looking for the final result of the problem. I'm looking for what goes here. Well, I notice that I've got a donut on top here, but there's no donut anywhere in the answer. So that means that I must have canceled out the donut somewhere in the middle of the multiplication. And that means that that donut must have gone down here. It's my best donut, don't make fun of me. And that allows me, if I put that donut in the bottom, that allows me to cancel it, just leaving the smiley face. Why am I doing all this crud with shapes? Well, it turns out you can do it with units as well. Okay, you can do it with numbers, as I did up here. You could do it with shapes. You can do it with anything. Let's do with units. In a prior video, I talked about converting from milligrams to grams. Okay, so I could say 8 milligrams equals how many grams. And I could use the ladder method for that. But with this unit cancellation method, what you do is you recognize that I'm going to take 8 milligrams and I'm going to multiply that by something over something. And in my final answer, I'm going to have grams. Well, just like with the shapes, if I don't want milligrams in my final answer, right, just like I didn't want donut in my final answer here, I ended up adding a donut to the bottom here so that they would cancel. Well, I don't want milligrams to be in my final answer down in this example, so I can put milligrams in the bottom so that they cancel. I do need grams to show up in my final answer, so that means on top I must have grams. And now my last step is to look at what are the numbers that fit in here. And really, what this chunk of equation is asking us is, what's the conversion factor for grams to milligrams? In 1 gram, how many milligrams are there? It's 1,000. And if you don't know that by heart, you can look it up. So now I've canceled everything I can, and what's left to do is multiply all this out. I've got 8 times 1 with grams on top, and on bottom I have 1,000. So my final answer here is 8 thousandths of a gram, and if you punch that into the calculator, you get 0.008 grams. And this matches with the ladder method. If you're going from milligrams to grams, on the ladder method we would have had to move the decimal left 3 places. And so the decimal used to be right here, and I went 1, 2, 3, and that works. So we get the same result, and that's a good thing. Okay. That's all I'm going to tell for now. In a future video, I'll go deeper into this unit cancellation method. Again, it's not just a replacement for the metric ladder. It's a way to convert from one unit to any other unit, right? We don't just have to stick with metric anymore. You could use this method to go from feet to miles, or from feet to centimeters, or anything. You will see the power of it in the future. Have a good day.